And welcome back, ladies and gentlemen. We are now going to be talking about debugging programs in the simulator. So we've talked about some of the different techniques, some of the different errors, but now let's actually look at a program and try to troubleshoot it. So let's get started here. We've experienced so far an ideal situation of seeing a program that works perfectly the first time. Right, we had our add nums program. It just worked great. So let's look at a more realistic challenge, realizing that a program has a problem and then trying to track down that problem in order to fix it. In these next few lessons, we're going to examine a program with an error, and then we're going to debug it. So here's our first one. Program, in this case, we have to debug, it's a multiply, but there's no multiply instruction. Just remember, there's only add, and not. So we have to be a little creative. So in this one, this program is supposed to multiply the two unsigned integers in R4 and R5. So in this case, let's set R4 to 10, R5 to 3. If you run the program, you get R2 is equal to 40, not 30. And when we look at our example, we'll use some different numbers. They're a little simpler, but it's going to have the same thing. Pretty much what it's supposed to do, if you follow the flow chart over here, you can see that you clear register 2, add register 2 to register 4, decrement register 5, see if register 5 is equal to 0. If it's not, loop back up here and repeat all the way until register 5 is 0. Once it does, halt your program. And then, of course, these are the corresponding lines of code that would be for this particular instance. But let's look at another one. We're going to make ours just a little simpler in some aspects. All right, so let's go ahead and this is the program what we're going to use. So let's go ahead and enter the program first in LC3 edit. So, of course, here's our first one. You notice this is in binary. This is the address where the program begins, and that's, of course, this time in 3200. We're going to clear register 2. We're going to add register 4 to register 2 and put the result in register 2. I'm going to subtract 1 from register 5 and put the result into register 5. I'm going to then branch to location 3201 if the result is 0 or positive. In others, it's a loop here. And then we have our halt command. So it's a pretty simple program. Now, what the program does. As you can tell by studying the program, the contents of register 4 and register 5 are going to be multiplied, quote unquote, by adding the value of 4 to itself some number of times. Because remember, multiplication is really just a faster way of addition, specified by the contents of R5. So, for example, 2 plus 2 plus 2 is the same thing as 2 times 3. So it's the same thing, it's just we're using addition to do multiplication. For example, if register 4 has the value 7 and register value has the value 6, we want to add 0 plus 7 the first time, then 7 plus 7 the second time, then 14 plus 7 the third time, then on and on until you get 35 plus 7 the sixth time through, ending up with the value of 42 in the register 2 when the program finishes. So once we finish typing up our program in the LC3 editor, we're going to save it as multiply.bin, so this because it's a binary file, and then we're going to click on that conversion button to convert it over to an object file. Then we're going to load that program into the simulator. So let's start the simulator and load our program, multiply.obj. Now the memory portion of the simulator will look like this, and you'll also notice that the PC contains the value 3200, which corresponds to the blue arrow pointing to that line, the next instruction to be run, which happens to be the first instruction of the program which we haven't started running yet. So let me just go ahead and pull that up here in just a second. Okay, so I have the simulator up here. So I'm just going to go ahead and open up that multiply file here. And you can see that the address is updated to, say, 3200 here instead of 3000. All right, and here's those corresponding lines of code that we put in. Okay. Now we need to set our breakpoint at the halt instruction. And we should always make it a habit to set the breakpoint on our halt line, because if you run a program without that, you'll end up in the halt subroutine, which will change some of your registers before the machine actually comes to a halt. So first we're going to set a breakpoint at line 3204 by double-clicking the little gray square at the beginning of the line. So let me just go there. So line 3204, there's a little gray square right here. If I double-click that, line 3204 now looks like this. All right, that red stop sign tells us that a breakpoint is set, so the program is running and the PC gets to that value. The simulator will pause and wait for you to do something. All right, let's get ready to run the buggy multiply program. Now, before we can run our program for the first time, we have to put values in register 4 and 5 so they can be multiplied, or not in this case since we know there's a bug on the program. But if we didn't know there's a bug on the program, this is how we would do it. So we have to ask ourselves, what values should we choose to test? Because I could theoretically plug in any kind of decimal number here to try and do this, or a hex number. Well, we're going to pick two numbers that are reasonably small, so something like 5 and 3. These numbers are easy for us to do in our head and will also act as a good test of the program. So if we want to set the value, we're going to click on that icon right there, set value, and we're going to get a pop-up window. In the location field, we're going to choose register 4, and for our value, we're going to type x5. So you'll see this like you see right here on the screen. Then we click apply, which means set the location I've just picked to the value I just entered, but leave this pop-up window open so I can type more stuff. Now choose register 5 in the location field and type x3 in the value. Then we're going to click OK to close the pop-up window. Now your register is set and you're ready to begin running the program. So let's go ahead and do that here in our simulator. So I'm going to go right up here, click that set value icon. I'm going to choose, you can see I have in here PC, X, IR, PCR, CC. What I want to do is just in here, I remember if you recall, I want to set the value to register 5. And register 4 first, and I want to set that to the value x5, and click apply. Then I'm going to come up here and do register 5, and I'm going to set that to x3. Then click OK. And you can see that my registers have been updated, so register 4 is 5, and register 5 is 3. So let's go ahead and run that debugging program. So to run our program to the program, we click on Run Program. For a second, we're going to get a pop-up window that looks like this. So let's go ahead and do that. I'm going to run the program. Bing, there's my pop-up. It says PC equals 3204. So just click OK. So that happened because we set that breakpoint at the halt line, and we clicked OK to close the pop-up. Now let's go ahead and take a look at register 2, which is supposed to contain the result now that we've run all but the last line of the program, which of course is the halt command. So if we look at register 2, we see the value 20. As you may know, 3 times 5 is 15 in decimal, but register 2 is 20 in decimal, which is x14 next. So obviously something went wrong. Now we need to figure out what that something was. So we're going to do some stepping through, because since that's the first technique that we've discussed, in order to figure out what went wrong with our multiplication program. One option for debugging our program is to step through the entire multiply program from beginning to end. Since we have a loop, let's approach debugging a different way. First, let's try stepping through one iteration of the loop to make sure that each instruction does what you think it should. So let's go ahead and double click on the R5 near the top of the interface. This will bring up the set value window. Set the value of register 5 to 3 and click OK to close the window. So let's go ahead and do that. So we're going to double click on R5 and we're going to set that to 3. Now click once on memory location 3200 and we're going to click the blue arrow there. So I'm going to click once here. I'm going to click the blue arrow. See, that's setting the program counter to whatever memory location has been selected. The blue arrow is now pointing to the first line, and the two registers you need are initialized to the values you want. So we're ready to step through the program in our first attempt to figure out what's going on. So if we look here, 5, 3, and that's back to 3200. So now we're going to click step over, and you'll notice that several things change. So I'm going to click the step over command, and you can see immediately that things have changed. The program counter now points to the instruction 3201. The instruction register has the first instruction 5480. Register 2, which a moment ago contained our incorrect result, decimal 20, is cleared. This is exactly what you should have expected the first instruction to do. So let's keep going, because you want it to clear out all of those registers there. So let's click step over again. And you can see that once again, the program counter and instruction register have changed as expected. Now register 2 contains the value value 5, the same as hexadecimal, by the way. Again, this is what you want, so keep going. So if we look, register 5, register 5. So now the next time, though, if we click it, we should see the value of register 5 change from 3 to 2. So let's go ahead and click that again. You can see that has changed. We're not going to keep mentioning the program counter and instruction tracer, but you can notice those keep changing after each instruction. Register 5 has double purpose in this program. It is one of the numbers to multiply, but it also acts as your quote-unquote counter. It tells you how many more repetitions of the loop are left to go. So each time through the loop, register 5 gets decremented. That seems to happen just fine, so keep going, because it went from 3 to 2. Stepping through continued. So we're going to continue the step through again to cause more execution to happen. So if I click again, so it jumps right back to the beginning of 3201. When a branch instruction executes, one of two things can happen. Either the branch gets taken or it doesn't. In this case, the branch got taken. Why? Because the branch test, the condition codes were set by the add instruction before. The result of the add was x2, a positive number, so the P register was set to 1. Your branch is taken if the 0 register or the P register contains 1. If the branch was executed and the branch was taken, the program counter now points to 3201, ready for another iteration of the loop. Alright, so stepping through the program for one repetition of the loop has shown that there's nothing wrong with any of the individual instructions of the loop. So, because the loop went just fine. So maybe the problem lies instead with the way that we have that loop set up. So we're going to have to try a different approach. Alright, at this point I'm just going to kind of stop us on our debugging prep because this is a lot of information to digest. But obviously we haven't found a solution just yet. So, in a quick recap, there's an error with our multiply program. We tried testing using the step-through method to see if individual lines of codes have an issue. However, all the individual lines of code are doing as they should, so we're going to need a new method besides tracing to determine the error in our program. Alright, and that concludes our notes, folks. Until next time.